Hi everyone, welcome to another video of my CCNA series, and in this video we are going to talk about a floating route. So in the last video we talked about the RIP and how does that protocol work, and in this video we are going to see how floating routes work and what is the use case for a floating route. Let's begin this video. Before going to the floating route, we have to know a concept called AD, which is administrative distance. So each route in a route table will have some administrative distance. So for example, if that is a connected route, so AD will be 0. For a static route, AD will be 1. For EIGRP, it will be 5, 20 for BGP, 110 for OSPF, 115 for ISIS, and 120 for RIP. Let's understand the use of the AD first. So suppose we have 4 different routers and 2 users are connected. One is here user number A and second one is here user number B. Now suppose A want to send data to B, and this is a static route. So this one is a static route, and between these there is a RIP route. And this is a static route, and then between these there is a OSPF. So basically the traffic will go to this router. So traffic will go from A to this router. Now this router will calculate the distance to a destination with the help of AD. So basically this will be AD1 plus this is RIP, so this will be 120. So the route, the path it will take is 120. Then the second one it will calculate. So this static is 1, and then OSPF will be 110, and total of them will be 111. So basically 111 is short. So traffic will always go through this route, basically this and this route through static and then OSPF. So this is how an administrative distance work, and this is how a router decides a route. So whatever AD is the shortest one, the router will show that in his routing table. That will be used for routing purpose. Now we are talking about floating routes. So let's remove all this static BGP, ISIS, RIP, and let's configure some floating routes. So let's talk about some floating route. So basically whenever we configure an router and static route, so the command is IP route, IP route, then we will write the destination's IP address, suppose anything 10.10.10.1, then we will write destination subnet mask, which can be 255.255.255.0, which will be /24, and then we will write either the IP address of the interface or an interface name like SE2/0, something like that. And then we have also an option to write administrative distance. So we can choose an administrative distance between 1 to 255. So 255 can be the the most administrative distance, and 1 can be the least one. So basically we can write 1 or 255 here, between any number in between these two. So let us write 2 here. So basically IP route. So whenever we configure route on this particular router, so we will configure this as a floating route of 100 and this as a floating route of 99. So basically we will configure it accordingly. Now the router will always follow the 99 path. So this one. Now what is the benefit of floating route? Suppose this interface suddenly goes down or this interface suddenly goes down. So path will be automatically take over by this route. So this route won't be used anymore if something is broken in between. So this is the functionality of floating route. So suppose we have multiple routes to a same destination, and we have static routing configured, or even suppose RIP is configured, right? So we can configure another route as a backup one. So this route, in this case, this one will be a backup route, and this one will be your normal 99 distance. But if anything breaks down here, so this will be your backup route. So floating route is kind of a backup route. You need to remember it as that. Now we are going to see an example on Cisco Packet Tracer of a floating route. And please remember this administrative distance, and also remember that in the exam you will be seeing 2 or 3 simulation based question definitely on this concept of floating route. Either it will be mixed up with an RIP, or it will be mixed up with a static protocol itself. Let's go to this example. So now currently this network is 192.168.10.0, this network is 20.0, and we have either this route or a route via router number 2. So first route is laptop 0, router 1 and laptop 1. The second route is laptop 0, router 0, then router 2, then router 1, then laptop 1. So basically there are 2 different routes. Now I have statically assigned all the routes in this routing table. Administrative distance for this route is I have assigned as 10. Administrative distance for this I have assigned as 3. And administrative distance of this I have assigned as 5. So if suppose traffic comes from laptop 0 to router 0, it will always go via router number 2, because the administrative distance here will be 3 plus 5. So total of 8, and administrative distance over here is 10. So basically it will follow the second route. Now to test that, if I go to the laptop 0, first let's see the route table of all the routers. So I'm in router number 0, enable configuration terminal and do show IP route. Now if you see here, the router is shown as 10.0.30 is connected via 172.16.10.2 and 172.16.10.0 is connected via this. A 10.10.10.0, if you see, this is connected via serial 2/0, and it is a directly connected route. So directly connected route although has an administrative distance of 0, but I have assigned this administrative distance as 10. So if we try to find out, if we try to do a trace from this, so I'm going to do a trace from 192.168.10.2 to 192.168.20.2. So one trace RT 192.168.20.2, and if you see, the traffic is going through 172.16.10.0, then 10.10.10.2, then 192.168.20.2. So basically router 0, router 2, router 1, and then laptop 1. Now suppose this line breaks down. So this is serial number 2/0, and I go to router 2, enable this. Suppose I go to the graphical user interface, serial 2.0. I off this route. So this route is now red. So the traffic will go through the backup route. So this is set up as a backup route. So traffic will go through here. Now if I try to do the same trace route, you would see that now the traffic is going to 10.10.10.2. This automatically came up. This route automatically came up when this went down. So if I again go and enable this, and then I again try to do the same trace route, now it will take some time. Let's see. See, now it is going to 172.16.10.10.10.0. So basically floating route, this one we have configured as floating route. Whichever route has the more administrative distance will be configured as a floating route. So in case either this route or this route goes down, so either router 0 and router 2 loses connectivity, or a connectivity loss between router 2 and router 1, the floating route will be used to communicate between laptop 0 and laptop 1. So this is basically a very simple example, and you can also configure it in your Cisco Packet Tracer. Do watch my static route and RIP videos, and then configure your own route and design your own route and design your own routing table. So thank you for watching. This was all about floating route. Please let me know your suggestion in the comment section down below, and I will see you in the next. Take care. Goodbye.